1, 2, 3. We specialize in downhole drilling tools. We make measurements downhole at the bottom of an oil well during the drilling process, telemeter this information to the surface in real time. One of the interesting technologies that's part of this industry is the use of mud pulse telemetry, where we open and close valves to make pressure pulses in the fluid flow and use those pressure pulses to encode data and send it to the surface. And of course, to do this, you need electronics, you need valves, you need sensors, you need surface equipment. And Rime specializes in that particular industry. One of the first steps in the design of any product is mechanical design. We start with mechanical assemblies, individual parts, which become realized 3D model of one of our products. This is a model of one version of our Slick HD pulser. We have the working end, which is our valve. We have our drive train, which is from about here to here. It's the gearbox, oil, and all the other things we need to make the drivetrain work. We have electronics and the motor, the actual device that moves the valve. A design like this is hundreds of parts and it's thousands of hours of work. Every dimension, every thread, every part is neuroticized over. So once we have a realized mechanical design, we move to digital simulation. It's hard to test products in the oil and gas industry simply because it is hard to get our equipment downhole in a prototype stage. So we do a lot of work ahead of time to validate the design of our products with basically fluid simulation, vibration simulation, multi-physics simulation. This, for example, is flow velocity through a valve in one of our products. It's a very detailed design, and we do this on all products, especially all products that have to do with mechanical fluid environments. Once we have a result from such a test like this, we use it to optimize our design, and we go back and forth from design to modeling to arrive at what we think is a good optimum solution between what the product needs to be and what can actually be achieved. And we're trying to balance not just performance, we're trying to balance cost, usability, operating cost, manufacturability. Electronics and software is a huge part of our business. Circuit schematics, we design all our electronics ourselves, chip by chip, board by board. We lay out our boards ourselves by hand. Once that's done, we render all of our designs in full 3 dimensions to make sure components fit, clearances, thermal effects, vibration, mounting. All of these things are dealt with at the design stage. Once we go through this entire process, we have a product that is ready to be manufactured and tested. Modern measurement while drilling tools aren't just metal, wires, and electronics. A huge part of what we do is firmware and software. The development of the firmware, which is the code that runs on microprocessors in our downhole tools, and software, which is the code that we run on our surface equipment to communicate with our downhole equipment, is a significant part of what we do as a company. Hundreds of thousands of lines of code developed over almost a decade. There's the ability to not just understand how a product works, but how it worked, when and where and in what condition. The first step is the manufacturing of our electronics boards. We hand manufacture all of our boards in-house. Our technicians have decades of experience. The art of assembling electronics boards to work in rugged downhole environments is nowhere near as easy as, for example, the manufacture of a commercial device. We have to use specific types of solders, specific materials for the boards. Components have to be screened, components have to be selected to work in the environment. How our boards are manufactured makes a huge difference to the quality and reliability of our products. The assembled electronics board is then harnessed with appropriate connectors depending on the product and the customer. The harnessed board is now connected to our power supply and it is programmed with the firmware. The programmed board is conformally coated. The coated board is allowed to dry for several hours to adhere all the components to the board. After the conformal coating step, specific components on the board are epoxied down and rubber is added in select areas to maximize vibration protection and mechanical ruggedness. The fully processed electronics boards are now fully encapsulated in a silicone RTV for shock and vibration isolation. The assembled board that's been potted and epoxied is wrapped and inserted into a chassis Assembled chassis are then rigorously tested in our Halt-Haas chamber, simulating extremes of temperature and vibration. We also rigorously qualify new designs with our shock and impact test table. We can have different targets in the machine to simulate different amplitudes, widths, and shape of impacts to qualify our devices for severe shock and vibration environments. All cable harnesses at Rime are rigorously tested using our high voltage high-pot tester, where cables, their connectivity, and their impedances are checked at voltages between 50 and 1500 volts to ensure low leakage and reliable electrical connections. The electronics is then tested for the sensitivity and behavior of the flow switch using our electrodynamic shaker. The electronics, the motor and gearbox, and the harnesses are then assembled to finish the electronics section of one of our pulsers. Most of the mechanical parts of Rime Downhole products are custom engineered, but also manufactured specifically by us. And these products are, again, thoroughly quality control checked before usage in any downhole product. The assembled pulsar drive section is now oil-filled using Rime's oil-fill station. Most of the way through the oil fill, the oil station stops and lets the user set the compensation piston to its correct position. After the oil fill is complete, the oil fill plugs are put in to seal up the compensation chamber of the pulsar. At this stage, the piston assembly tool is removed and the valve components can be assembled onto the drivetrain of the pulsar. Additional grease is added in front of our piston compensation system to exclude contaminants and debris from the seals for as long as possible. One of the many interesting features of Rime's Slick HD servo pulsar product is the fact that our electronics and our motor and gearbox reside in air, not in oil. This gives us significant advantages as far as corrosion and erosion go during downhole use. The use of the magnetic coupling allows us to open and close the valve with all the critical high wear and, more importantly, the fragile components of the tool kept in air in a nice controlled environment, while the valve itself is in a pressure compensated environment. At this stage, the drive shaft and valve components of the pulsar are ready to assemble to the electronics. The pulsar is connected to our pulsar interface program software through our pulsar interface box. The pulsar is pulsed continuously using our software to verify that the energy consumed is within acceptable limits and that the valve's full range of motion is checked visually and using our software. The sensitivity and the behavior of the flow switch sensor on the pulsar is again tested to ensure that everything is working perfectly before shipment. This Rime Servo HD pulsar is now ready for shipment to a customer.